All right, today I'm going to talk about the prerequisite section 2, linear models and rates of change. This is very much Algebra 1 stuff, so you should find this pretty easy. Let me just say that lines and rates of change really a big topic in calculus and something we're going to be referring to quite a lot this year. So it's important that we're really good at this stuff. Okay, so let's just start off at the beginning. Slope, you all know slope. Slope, rise over run. Okay, another way to look at that is delta y over delta x. This is a little bit of a more mathy explanation. So delta y, delta means change. So change in y over change in x. So that'd be your rise. Run would be change in x. And of course, if I'm given 2 points, call them x1, y1, x2, y2, right? So just 2 distinct points. We find the rise over run by subtracting the y's over subtracting the x's. Make sure whichever one you start with goes first in each. And then our 2 x values cannot be the same. If our 2 x values are the same, then our slope is undefined. It's a vertical line. And we'll talk more about that. Okay, so there's basically 4 options for our slope. Option 1. And once again, slope, typically we use the letter M to denote slope. Why that is, I don't entirely know. So this would be a positive slope. This would be a negative slope. A horizontal line would be a slope of 0. A vertical line would mean your slope does not exist. Undefined slope. Okay, so pretty basic so far. All right, so let's talk about some different forms of a line. Actually, in calculus, we use the form that is really the easiest, which is point slope. Let's talk about this. So point slope is the most common form that we'll be interested in, and that will become more apparent later why that's important. I'll just say it typically is because we have a point and we have a slope. So the point would be x1, y1, and then of course m would be the slope. Okay, so point slope form of a line, y minus y1 equals m x minus x1. Now, I think in the CPM book, they move the y sub 1 over there. If you want to do your point slope form this way, that's fine too. And in fact, there's some advantage to doing that, like if we're trying to represent things as functions or doing piecewise functions or something like that. This might even be better. I tend to use this just because it's sort of a habit, but it really doesn't matter at all which one you use. Okay, so this is really basic. If I give you a point, so let's say I give you the point -3, 4, and I give you the slope of 7, okay? What's our point slope form? So it's really easy. Y minus 4 equals our slope, and then x plus 3. That's it, I'm done. That's point slope. I'll say that, you know, in the past, maybe your past algebra teachers, algebra 2, etc., pre-calculus, perhaps they had you simplify these, putting these in slope intercept. I would only do that if you're specifically asked to put it in a particular form. If they just ask for the equation of a line and they give you the point slope, just leave it. One thing about calculus is that algebraic expressions, generally we don't worry about simplifying like perhaps you did in past classes, unless it specifically says simplify this. Okay, so that would be perfectly fine. Now, if I wanted to graph it, now you could change this to slope intercept, the old y equals mx plus b. okay? But you really don't need to, because we can plot it from here, right? So 1, 2, 3, 1, 2, 3, 4. Why I chose a slope of 7, I don't know. 4. So let's see. 4. What was that? 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so rise 7, run 1. So we get a graph that looks something like that. All right. Now, if we didn't want to change this to slope-intercept, if they specifically asked for it, there's two ways to do it. Sort of the most common way is that we're going to solve this for y. So this would move this over here. I'm going to distribute the 7, so plus 7x plus 21. And then, of course, I get y equals 7x plus 28. And you can see that that's pretty steep, so that's going to intersect somewhere up there, y equals 28, 0, comma 28. Another way to do this is if you just leave it in this form and then you just let x equal 0, that's another way you can get the y-intercept. Since we already know that the slope is 7, so this would be y is equal to 4, just move that over there, and then this is going to be plus, and then that's going to be 21. Wait a second. My math is wrong. I apologize. 21, good thing I checked. 4 plus 21 is 25, not 28. Okay, so we can see that that checks out. So however you want to do that, it really doesn't matter to me. And once again, only put it in slope-intercept form is if they specifically ask, okay? Now, one of the things that we always want to remember, and one thing we'll do a lot in this class is we'll do applications. Slope is rate of change. Slope is rate of change. So for instance, if I say something like, like a typical thing is, let's say I want to make t-shirts, and there's a t-shirt company and I have to pay a setup fee of $100, and then each t-shirt will be $10. So each t-shirt will be $10. That means that $10 would be the slope. The y-intercept would be the $100 setup fee. Things like, I could use slope as like, if I'm thinking about filling my car with gas, right? And gas costs, I think I saw this morning, $2.05. So that would be the slope, right? So with each gallon I put in the car, it goes up $2.05. So always think of that rate of change, as in rate of change would be dollars per gallon, dollars per t-shirt. Any of those things typically are going to be a slope. Now, in linear relationships, the rate of change does not change. It stays the same. The slope is fixed. It's a constant. A big study of calculus is talking about rate of change with functions that the slope does not remain the same. Okay, so let's talk about the different forms here. So we have the point slope, slope intercept, which is probably the form you've worked with the most. This is actually the form we like the best in this class. M is the slope, B is the y-intercept. And then another form, which is one that they refer to in the book, it's not one I would worry about too much. This is general form. And general form is AX plus BY is equal C, where A, B, and C are integers. So in other words, they're whole numbers. So if there's a fraction, you've got to multiply by a common denominator, so all those things become integers. So there are some exercises that we'll do that they do ask for general form. So that would be what you want to focus on there. Okay. So let's talk about parallel and perpendicular lines. Okay. So parallel lines. Slopes are equal. Okay? Perpendicular lines Slopes are opposite reciprocals. Okay? Now what I mean by opposite reciprocals, if one of them is positive 3, the other one is negative, and then 1/3, or vice versa. Okay, so one's negative, one's positive. Okay, so now let's say we're given a point, so this is a common thing. So let's say given the point 25, write the equation of a line parallel to, and then 3x minus y equals -2. Okay, so the big trick here is we need to find the slope of this, so we know the slope of this is going to be the same. Probably the easiest way to do this. Now, I will tell you, you can look at this and see what the slope is, but generally just put it into y equals mx plus b form is probably the way you're going to remember to do this. So that's what we'll stick with. So here, if I move the y over here, add the 2, I'm going to get y is equal to 3x plus 2. Okay, so my slope of this line is 3. Okay? So if my slope is 3, then through that point, once again, I'm going to use point slope, so that'll be y minus 5 equals 3, and then x minus 2. So that will be parallel. If they ask for the perpendicular is going to be the same point, except the opposite reciprocal slope. So that would be -1/3. If the original was negative, this one would be positive. Okay? So that's the perpendicular. Now, once again, if all it asks for is point slope form, then we would leave it like that, and we would be done. Okay? But if they ask for slope intercept, or excuse me, slope intercept form, then we want to end up solving this. So slope intercept, once again, I'll do this the other way. So what I'm going to do is I'm just going to plug this in for 0. So if I want to find what my b is, y is equal to 5 plus, and I'm going to plug 0 in here, which will give me my slope intercept, or my y-intercept, excuse me. I'm glitching a little bit here. That's going to give me -6, so that's going to give me -1. So this would be y equals 3, x minus 1. If you want to do it that way, go for it, but that would be slope intercept form if they're asking for that. And then over here, let's say we want general form. So general form, so this is slope intercept form, of course. General form is probably the one that you know the least. But let's put this in general form. General form, once again, is just where we have it in this ax plus by is equal to c. In that particular form, a, b, and c are all integers. So the first thing I want to do is I want to get rid of that fraction. So the first thing I'm going to do is multiply everything by 3. Okay, so that's going to be 3y minus 15 is equal to, now realize there's 3 different things here. There's the y, there's the -5, and then this is one quantity. So if I multiply this all by positive 3, I'm going to get -1 here. Okay. Now, if you do that, it's going to make this a lot easier because then you don't have to work in the infinite common denominator. So now I'm going to distribute this 3y minus 15 is equal to -x plus 2. Okay. And now let's organize this so everything's on the same side. So I'm going to put the x over here. So this will be positive x, because I'm adding it to the other side, plus 3y. And now I'm going to add the 15 over here. That's equals 17. And that is general form. Okay. I think that's going to do it for lines. There's a lot we're going to be doing with this this year. There's a lot of applications. There's some application problems I'm going to have you do. As far as those applications, just keep in mind that the slope is going to be the rate of change in that problem. But that's basically it for prerequisites section 2.